All right, so today we're going to start talking about increasing and decreasing functions. Your notes have this little spot for you to write, so go ahead and write that stuff in. Pause your video, I'll wait. So essentially what this is saying is a function's increasing, or it's getting bigger, on an interval between two x values, so say x1 and x2, as long as my first x value is smaller than my second x value. Therefore, when I plug this into the function, my y values should be the same. If x1 was smaller than x2, then the y, or f of that, would be smaller than f of the other. The function therefore is decreasing if x1 is still smaller than x2, but the opposite happens. The y values are getting smaller as we're going, so therefore x1 would have to be bigger than x2. Excuse me, the y of x1 would have to be bigger than the y of x2. So let's look at that pictorially. So we have this little graph here for us, and we're going to put some labels on it, so don't just skip to the next page already. We're going to talk about when it's decreasing, increasing, and constant. So say we're given some, that's still not what I want. Say we're given some interval, and our interval is a to b, where a to b is are my x values. So my interval here is a to b. So let's say a is this line. So that's where x is equal to a. And this other line is where x is equal to b. So we're just looking at some interval or some frame space. On this interval, when we approach a, if we take a look, here I'm following it down, my x values are smaller while my y values are larger. So since my x values are getting bigger, my y values are getting smaller, this is an example of decreasing. If we take a look here from b, as we go onward, x's are getting bigger, y's are getting bigger. This is an example of increasing. Sorry guys, still a little sick. So this little part here in the middle, nothing's going on, so we are used to saying this constant, or it stays the same. Why do we care about this when we're talking about derivatives? What the heck does this mean? Well, when we're decreasing, or we're looking for the slope of a decreasing function or decreasing part, my f prime, which is my derivative, will be less than 0. When I'm increasing, therefore, my derivative is going to be greater than 0. And then when nothing's going on, that is where my derivative is equal to 0. So it's going to help us in the upcoming definition. So again, you have spots for the next 3, so please pause. This next part of your notes just is rewriting, so pause and continue on as you needed. Oops, sorry. Before I go on, I want to talk about this. So again, this is going back and talking to you about how when it's greater than 0, what we just kind of talked about. So next slide is again more writing, guidelines of stuff you should have numbered. I think I numbered it for you. Go ahead and pause and write this down, then we'll come back and talk about it. Alright, so today we're going to talk about finding intervals about increasing and decreasing stuff. So first what we do is we find the critical points, and then we use them to do the test, the interval test. Then we determine the sign of it, and then we see if it's increasing or decreasing. So this is more of one of those need to hands-on practice. So first steps first. I find my critical points. So I find my critical points by taking the derivative and setting it equal to 0. So the derivative of this function, I gotta skip here a little bit. The derivative of this function is going to be 3x squared minus 3x. Because when you multiply that 2 down, the 2 cancels each other out. Excuse me, the denominator of 2 multiplying cancels the multiplication of 2 out. So I take that, set that equal to 0. Factor out of 3x. I'm left with x minus 1. So we get x is 0 and x is 1. So we found the first part. Ooh, sorry guys. So we found that first part of our critical points. Now what we need to do is find the actual coordinates for those. So we're going to go back up. I'm going to write it over to the right over here. We're going to go back up and we're going to plug those into the original function. Move my graph over so I have more writing room. So we're going to have f of 0. So when I plug in 0 to the original thing, I should get 0 pop out. And then when I plug in 1 to the original, I should have negative 1/2 pop out. I'm going to fix that 0 because that 0 looks like a 6. Much better. So now I have 2 points. I have a point at 0, 0. And I have a point at 1, negative 1/2. So these are kind of close to each other. In the next example, they're not so close. So now what we need to do is we need to figure out what my graph is going to do. Is it going to go and look like this? Is it going to look like this? Is it going to look like a W with a weird thing? What's going to go on with my graph? What is going to happen next? So what we're going to do now excuse me guys, is I'm going to scroll down so I have room to work. And we're going to make a little chart that helps me determine what I'm going to do. So we're going to talk about the left side of my graph here, and I'm going to talk about the left side from my leftmost point. So we're going to talk about from negative infinity to my first point of 0. So from negative infinity, when x is less than that and is less than 0. So I'm talking about all smaller parts in that first part. And I'm going to find out what happens on there. Then, if I scroll up, I'm going to find out what happens in between my 2 points. So that's going to be when I have 0 is less than x is less than 1. And then I'm going to have the right part over here, and that's when x is bigger than 1. So x is bigger, excuse me, 1 is less than x is less than infinity. So what I do, according to my first couple slides that we wrote stuff down for, is I'm going to pick a value in each one of these categories that satisfies each category. So for example, this first one, it's got to be less than 0. Okay, so I'm going to plug in negative 1. And I'm going to plug that negative 1 into my derivative. And what I'm wanting to do here is to see what kind of a value I get. Now, I don't actually care what value you get. I want to see what kind of value. So that being said, if I plug that in, I have 3 times negative 1 squared minus 3 times negative 1. So negative 1 squared gives me 1. 3 times 1 is 3. Negative 3 times negative 1 gives me positive 3, so I have 3 plus 3, which is 6. So now this is saying that I have 6, so that's a positive number. So I'm going to write an I here for saying I'm increasing. So my function is going to be increasing from negative infinity to that point of 0. Next, I'm going to do my next category. So I have between 0 and 1. So I'm going to pick 1/2. So when I plug in 1/2, it's going to give me quite a small number. The number is actually going to be negative. Correct? I'm plugging and chugging, right? We're going to get a negative number. So when that gives me negative, that means I'm going to have a decreasing function. Because again, if we go back to that first slide with the graph. And then this next one, I'm going to pick 2. And when I plug in 2, I see I still get a positive 1. So I have an increasing. So I'm going to use this information. I want increasing to decreasing to increasing. So from negative infinity to 0, I'm going to be increasing. So since I'm going to be increasing, as my x values get larger, my y values also get larger. So I'm going to look like this. Now when I hit 0, as my x values get larger, my y values get smaller. So I'm going to decrease. And then from once I hit 1, they're going to increase again. So using calculus, I can go ahead and sketch a graph of a cubic function. And for that matter, any kind of function, not just cubic. I can do 4th, 5th, 6th, 7th, however many I have. Let's take a look at this next one. So first steps first, we started by taking the derivative. So I have y prime is equal to 3x squared minus 12. Next, I took that derivative and I set it equal to 0. So 3x squared minus 12 is equal to 0. Let's solve for x. Well, let's divide out of 3. When I divide out of 3, I get x squared minus 4. That should be bringing in our heads of, hey, that's a perfect, the difference of difference of perfect squares. There we go. So then I get x minus 2, x plus 2. So my x values here are 2 and negative 2. So again, I'm going to move this over so I have some more room to work with. So we're going to go ahead and plug those numbers in. So I have negative 2 cubed minus 12 times negative 2 minus 5. Ooh, come on. Yeah. And that is going to end up giving me a positive 11. So my first point is going to be at negative 2, 11. And then the same thing I'm going to plug in 2 this time. So I have 2 cubed minus 12 times 2 minus 5. It's going to give me negative 21. So I have 2, negative 21. Now, I'm aware that I can't really go to 21 on this graph, or 11. 11 would not be too hard to get to because it's 1 over, but 21, a little bit. So what we're going to do is we're going to graph this by 2s, and so I'm going to leave myself a little note that says by 2s, so I'm aware. So I want negative 2, 11 is my first point. So since I'm going by 2s, I'm going to use the first one. And I'm going to go up 11, so 2, 4, 6, 8, 10, 11. So we're about there. And then my next point is to negative 21. So I'm going to go to the right one, and then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, a little bit past my graph. And now I have my 2 points. So now we need to figure out which way my graph is going. Am I increasing, decreasing? What is it going to look like? So let's go ahead and take a look at my 2 points. So last example, nope, we still have 2 points in this one. Just kidding. So when I read graphs, I go left to right, which is why I've been picking my smallest values. So if I go back a second, I started my graph with something that looked like this, which was very intense. So we're going to simplify it up a little bit. So I'm going to talk about the left side. So I'm going to say -2. Then I'm going to talk about the middle now. Because this one is the middle, I got to talk about how it's between 2 values. And then that right side is just going to 2. So I want to pick a value that is less than -2. So -3. If I plug in -3 to my derivative, do I get a positive or a negative answer? Doesn't matter the number, but do I get a positive or a negative? Good, I should get a positive, so I'm going to be increasing, because remember, if it's positive, it's increasing. Okay, logical number between -2 and 2. I always pick 0 when possible. If 0 is in there someplace, I use it. It makes my life easy. So when I plug in 0 into my derivative, do I get a positive or a negative number? Good, I should be getting negative. Same idea when I'm looking at the right side of 2. I'm going to pick one more, so say 3. I can pick any number. I can pick 10, I can pick 20. I just pick numbers that are easy. And that should give me an increasing or a positive value. So, draw this. From the left side, I'm going to be increasing, approaching this value. I gotta do this so I can. So from the left to the first point of -2, I'm gonna be increasing. Then I'm gonna hit it. I'm gonna decrease, and I'm gonna increase again. So like I said, my points aren't as close on the second example, but you kind of still get the same idea. All right, maybe. There you go. I'm so sorry. Okay, I want you to start this one on your own. Keep up with me. See if you kind of get the same answers. Okay? Remember, start by your derivative. Alright, I got my 2 critical points. Woohoo! Okay, once you get to this point, it's going to be way too hard to try and get this even remotely close. So we're going to guesstimate. Okay? Okay. Gotta make sure I can be able to see it on both. So we're going to be right up here. Now, my screen does not allow me to go any bigger than what you see, so I can't put this up any more than I have already. And same idea with my dot down there. Okay, so I have a pattern of increasing, decreasing, increasing. So increasing, decreasing, increasing. Now, I will tell you this right now. Not every graph pattern will be the opposite. They don't all magically work out that way. Sometimes they do, but for the most part, you have to do the other part just to double check that you know what you're doing. So please don't just pick one value and, oh, I'm increasing, so this has to be decreasing, that has to be increasing. No, because what if you accidentally messed up and you put this was decreasing the first, and then it throws off the other two. So you need to do all 3 steps when you check your numbers. So please don't just decide, oh, it's going to be this pattern every time, because it might not. So please, please, please make sure you do all those steps. Okay, there's your homework.